In the previous sections, we were looking at polynomial functions, finding the zeros and the roots. In other words, finding the x values when the equation is equal to 0. Section 3.4, we're looking at miscellaneous equations. So these are some that don't quite fit the pattern of what we've discussed in the past. One example would be the square root equations we'll be looking at. Some of our equations are also going to be working with absolute value, but they're going to be a little bit more complex than some of the ones that we did before. Alright, looking in your notes, you'll see the zero factor property. It states that if a and b are algebraic expressions, then the equation a times b equal to 0 is equivalent to the compound statement a equals 0 or b equals 0. Basically, this is telling us that if we've got a polynomial that we're trying to solve like this, we need to factor it first. Once it's factored, we can set each of those individual factors equal to 0 and then solve these smaller order equations for x. So looking at example 1, 30x cubed plus 16x squared minus 24x equals 0. What can I pull out of each term? I can see I can pull an x out of everything. I know I can pull out a 2, so that would leave me 2x times 15x squared plus 8x minus 12. Doesn't look like anything else is going to come out of this. So we're going to need to factor this using the a times c method. We're going to do 15 times negative 12. Let's just look at 15 times 12 first. What is 15 times 12 gives me 180. So I need to look at all possible factors of 180. I can do 1 times 180, 2 times 90, 3 times 60. These are all the possible ways that I can factor 180. In this list, we're looking to see if we can find a pair of numbers that we can add or subtract to give us a positive 8. How about the 10 and the 18? If we take the 10 and the 18, and we can make our 18 positive and our 10 negative. So now we can rewrite this inside trinomial with 4 terms and do the grouping method. So we're going to have 2x. I'm going to use a square bracket, and now I've got 15x squared. I can write my 8x as minus 10x plus 18x minus 12. And now I'm going to do the grouping method on those 4 terms. So in just the first 2 terms, I'm going to take out 5x. That leaves 3x minus 2. Here I need to pull out 6. That leaves 3x minus 2. Now I've got a common factor of 3x minus 2 that I can factor out of these 2 pieces. So that leaves me with 2x times 3x minus 2 times 5x plus 6 equals 0. This is now completely factored, so I need to set each of these individual factors equal to 0 and solve. 2x equals 0, or 3x minus 2 equals 0, or 5x plus 6 equals 0. This is going to give me 3 roots. I'll have, this one will be x equals 0, just divide by 2. You get x equals 0 here. Here, add 2 and divide by 3, we'll have x equals 2/3. And here, subtract 6 and divide by 5, we get x equals negative 6/5. And those are our 3 solutions. In example 2, we're going to solve 2x to the 5th equals 16x squared. Just like we had to do with the quadratic equations, we need to start by setting this to 0. So let's subtract the 16x squared on both sides. We'll have 2x to the 5th minus 16x squared equals 0. Then we need to factor. So I can take out 2x squared. I'm left with x cubed minus 8. You should recognize x cubed minus 8 as a difference of cubes. Remember, 8 is a perfect cube. So your formula for the difference of cubes, you may not remember it, but make sure that you are responsible for knowing those factoring formulas for cubes. This one, the formula is going to be a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Alright, so remember this is going back to material from the very beginning of the semester when we were reviewing. A is whatever you have to cube to give you your x cubed, and b is whatever you're cubing to give you your 8. So our a is x, our b is 2. So we're going to put that into our formula. We'll bring down the 2x squared, and we're going to be left with a is x, b is 2. So we're going to have x minus 2 times x squared plus 2x plus b squared, which is 4. Remember the trinomials that you get from those cubes, those special formulas do not factor any further. So we'll set each of these factors equal to 0 and solve. So we've got 2x squared equals 0, x minus 2 equals 0, and x squared plus 2x plus 4 equals 0. This one back here is easy to solve. I can divide by 2, and then that still gives me x squared equals 0. So and then take the square root, x equals 0 is my answer on this one. Over here I get x equals 2. And then I've got this trinomial that I need to solve for. We've already determined that it's not going to factor. So what should I do here? Knowing that that trinomial will not factor, that's going to tell me I need to go to the quadratic formula. So I'll have x equals negative b, so negative 2, plus or minus the square root of b squared minus 4 times a is 1 and c is 4, all over 2 times my a is 1. That gives me 4 minus 16, so that will be negative 12 over 2. Square root of negative 12 would be 2i times the square root of 3 over 2. And then I need to simplify this. And this gives me x equals negative 1 plus or minus I square root of 3. Alright, so this is our answer for this part. How many answers did I get here? I got x equals 0, x equals 2, and then I got negative 1 plus I square root 3 and negative 1 minus I square root 3. In your notes, you should have the 4 steps that we're going to follow for solving equations involving square roots. The first thing that we need to do is isolate our radical. That means we need to get our square root by itself on one side of the equation. To do that, I can subtract 2 on both sides. Once my radical is by itself on one side, I'm going to square both sides of my equation. So that gives me x equals x minus 2 quantity squared. Solving this for x, I need to expand this out. FOIL. And now I have a quadratic equation, so I need to set this equal to 0 and factor. So subtract the x. Hopefully this will factor for us. 1 times 4, they should both be negatives, and that does work. So we get 0 equals x minus 1, or 0 equals x minus 4. That gives us 2 possible answers. We got here, we get x equals 1, we got x equals 4. However, in our steps, step 4 tells us to check all solutions. When you're working with square root equations, You can get what they call extraneous solutions, meaning you might solve and get a value for x, but when you check it, it doesn't work. So anytime you're working with square root equations, you have to always check your answers. So if we put 1 back in here for x, does it check? If I put 1 for x, I've got square root of 1 plus 2 gives me 3, and then I've got that equal to 1, so no, that's not working. For my check, square root 1 plus 2 equals 1. So that does not check. My second one, if I put in 4, does that check? Square root of 4 is 2, 2 plus 2 is 4, and that's equal to my x, which is 4, so yes, this one checks. So my answer is x equals 4. In example 4, we've got 2 radicals. We're going to start by isolating one of the radicals on one side of the equation. You'll probably find that it's most useful to begin by isolating the radical that has the most stuff on the inside. That way you can eliminate that radical first. Let's add square root of x to both sides. Now square both sides. So that means I have to expand this out. I'll have 2x plus 1 equals 1 plus square root x times 1 plus square root x. Alright, so you're going to have 1 square root x plus 1 square root x, give you 2 square root x plus the square root of x squared, which is x. Now I need to work on isolating my second radical. So I can subtract 1 on both sides, and I can subtract this x from both sides, leaving me with 1x equals 2 square root x. Alright, and technically I don't have my radical completely isolated, but it's okay if you want to go ahead and square both sides with this coefficient in front of it, as long as you square your 2. So I'm going to square both sides here. That gives me x squared equals 4, and then if I square my square root of x, I get x. Now I'm going to subtract 4x on both sides, so I get x squared minus 4x equals 0, and I can factor this by removing an x. And now I can use my zero factor property, so I can set each factor to 0 and solve. X equals 0 and x equals 4. I still need to check my answers. So if I put 0 into the original problem, that's going to give me the square root of 1 minus the square root of 0, and that does check. If I put 4 into the original problem, that gives me the square root of 9 minus the square root of 4. So 3 minus 2, and that checks. So my answers are 0 and 4. We're going to solve x to the 4/3 power equals 625. Notice you've got this rational exponent. If you recall from the review sections at the beginning of the semester, we had a rule that told us if you've got a base raised to a rational exponent, this can be written as the nth root of that base to the m power. And this exponent can sit on the inside of the radical, or it can sit on the outside of the radical. So we're going to be using this rule. So how do we get this to just a regular x? If x is being raised to the 4/3 power, what power can I raise it to so that when I multiply my exponents, I get x to the 1st? Well, if I multiply 4/3 by its reciprocal 3/4, that will give me 1. So I want to raise both sides of my equation to the 3/4 power. And I'm going to do the same thing to the 625. There is one other little thing that you need to keep in mind. What happens if you recall your square root property? Remember when you had to take the square root of both sides of a quadratic equation, you always had to do plus or minus the square root of your constant, because there's more than one solution to that type of problem. Because this exponent up here is an even number, when I raise both sides to the 3/4 power, that's the same thing as doing a 4th root to it, and I'm going to need to do plus or minus, and then I'll do 625 to the 3/4 power. So again, it's like anytime you're taking an even root of, anytime you are applying an even root to both sides of an equation, you always need to use plus or minus on any constants that are affected. So that's why we had to do the plus or minus here. Now we can multiply these exponents. 4/3 times 3/4 gives us 1. So this is x to the first equals plus or minus the 4th root of 625 raised to the 3rd power. On your calculator, you can find the 4th root of 625. That is 100. The 4th root of 625 is 5. So we got plus or minus 5 cubed. So this is going to be x equals plus or minus 125. We can give our solution set as negative 125, positive 125. Example 5, part B, we want to solve y minus 2 to the negative 5/2 power equals 32. So again, what power do I need to raise both sides of this equation to so that this exponent turns into a 1? Well, negative 5/2 times what equals 1? Let's raise both sides to the negative 2/5 power. This to the negative 2/5. Now over here, should I do the plus or minus this time? This time my numerator is an odd number. So if you were taking the cube, let's think about a cube root. If you were taking the cube root of both sides of an equation, you would not need to do the plus or minus like you had to do with the square root, because because you're doing an odd root. So since we're taking a 5th root here, we do not need the plus or minus. And it all goes back to what happens with positive and negative numbers when you take square roots and cube roots, and if you're working in the real numbers. So because this exponent is odd, I do not have to do the plus or minus over here. So we'll just say 32 to the negative 2/5 power. Multiply these exponents, and we're going to get y minus 2 to the first equals, and then I need to simplify 32 to the negative 2/5 power. I know that a negative exponent is telling me to write the reciprocal, so I'm going to do 1 over 32 to the positive 2/5 power. So I have y minus 2 equals 1 over, and then this can be written as the 5th root of 32 squared. And what is the 5th root of 32? The 5th root of 32 is 2. So we've got y minus 2 equals 1 over 2 squared. So y minus 2 equals 1/4. Add 2 to both sides and you get y equals 2 1/4 or 9/4. We're ready to talk about equations that are quadratic in form. These are equations that we can turn into quadratic equations by doing a simple substitution. In example 6, you'll notice that you've got an even exponent here, x to the fourth, and then here you've got an x to the second power. We can do what we call u substitution. Let's let u equal, I'm going to erase this, I don't think I need it. I'm going to let u equal something so that if I were to square this, I could write it as, I want to be able to write this as u squared minus 14u plus 45 equals 0. So I just need to replace x to the fourth with something squared. I just have to determine what u needs to equal. It might be easier if you look at it here. I want this x squared, this whatever's sitting here, to be the same thing as u. So I can let's let u equal x squared. Does that work? If u equals x squared, then is this equivalent to what I had originally? Is x to the fourth the same thing as u squared? Well, if I square, if u equals x squared, if I square that, it would give me x to the fourth, which is what I need it to be. And then x squared is u. So in this problem, I want to choose u to equal x squared. So when you're doing u substitution, the tricky part is determining how to define your u. We're going to let u equal x squared, so that will allow us to write it as u squared minus 14u plus 45 equals 0. And now I can solve this by factoring. I can do 9 times 5. So I've got u minus 9 equals 0, or u minus 5 equals 0. U equals 9 and u equals 5. Alright, so I'm almost done. I still have to solve for x. To solve for x, I've got to substitute back. So I'm going to replace u with x squared. I'll have x squared equals 9, or x squared equals 5. Now I just got it back to, it's the same work that I was doing before, but I've got it back in terms of x now, and I can solve for x. So we'll take the square root of both sides. We'll have x equals plus or minus the square root of 9, so plus or minus 3. Over here, I'll have x equals plus or minus the square root of 5. And if I list all of the answers out, it's going to be negative 3, positive 3, negative square root of 5, positive square root of 5. Example 7, we want to solve x squared minus x quantity squared minus 18 times x squared minus x plus 72. This is another equation that is quadratic in form, meaning it can easily be expressed as a quadratic equation if we replace the x with another variable. We just have to decide how to define our u. So what should we let u equal? We want to have something squared here minus 18 times that same value. So let's let u equal the x squared minus x, because we've got x squared minus x to the first, x squared minus x to the second. Let's let u equal x squared minus x. We can then write this as u squared minus 18u plus 72 equals 0. Now we can factor this. That would be 6 times 12 and make them both negative. So x minus 6 equals 0, or x minus 12 equals 0. X equals 6 or x equals 12. I made a mistake. Alright? We're using u at this point. Sorry about that. Go back up. We've got u squared minus 18u plus 72 equals 0. This is what we're solving for. So when we factor it, I should still be using my u variable. So factoring this, I get u minus 6 times u minus 12. That's because now I set each factor to 0. U minus 6 equals 0, u minus 12 equals 0. I get u equals 6 or u equals 12. Right? However, I have to solve for x. so I need to express all of this in terms of x instead of u. So we'll back substitute here. We will replace u with the x squared minus x, and we're going to have x squared minus x equals 6, or x squared minus x equals 12. And I get two quadratic equations. Hopefully they'll factor for us. The first one, let's subtract x on both sides. You'll have x squared minus, subtract 6 on both sides. We'll have x squared minus x minus 6 equals 0. Does that factor? Yes, 2 times 3, and we want to make the 3 negative, the 2 positive. So we get x plus 2 equals 0, or x minus 3 equals 0. We got x equals, so that gives me negative 2 and positive 3. For my second quadratic equation, subtract 12. That gives me x squared, and I hope I'm still on this camera here. I'm going to move it down this way. So now we're going to solve x squared minus x minus 12 equals 0. And that should factor for us as well. That's going to be a 3 and a 4. Make the 4 negative, the 3 positive. X plus 3 equals 0. X minus 4 equals 0. So we get negative 3 and positive 4. So how many total answers do I have? I've got negative 2, positive 3, negative 3, positive 4. How many answers should you expect to get in these problems? If you go back and look at the original problem, we started out with x squared, and then that was also being squared, so this is x to the 4th. Remember, that means it has degree 4. The degree tells you how many answers you can expect to have. So with having degree 4, we got 4 possible answers, and that's appropriate. If we list our answers as a solution set, we would have negative 2, 3, and negative 3, 4 for answers. Example 8, we're solving 1 over x minus 3 quantity squared plus 2 over x minus 3 minus 24 equals 0. So how are we going to set it up? You'll notice you've got the x minus 3 quantity squared here. The x minus 3 again appears here. So that should give us a hint that u is going to be something related to this x minus 3. However, we do need it to be u squared, not 1 over u squared. So what if we move these into the top? Are we allowed to do that? Well, rules for exponents tell us that we can move them into the numerator and just change the sign of the exponent. So we can rewrite this first term as x minus 3 quantity raised to the negative second plus 2 times, and then the x minus 3 can go up into the numerator as raised to the negative first. So this is a little bit closer to what we need. How can we define u so that it can come out to be u squared plus u here, etc.? What else can I do with this? What if we let u equal x minus 3 to the negative first power, which is exactly what I see sitting right here. If I let u equal x minus 3 to the negative first power, what would I get if I squared this? If I square this, meaning I would multiply these exponents, it would give me what I have over here. So we want u to equal x minus 3 to the negative first. Now we can write this as u squared plus 2u minus 24 equals 0. And we can factor. It's 4 times 6. And make the 4 negative and the 6 positive. So we get u equals 4 and u equals negative 6. Now we substitute back in to solve for x. So we're going to have x minus 3 to the negative first so x minus 3 to the negative first, and this is, I think I'm going to go down because I'm a little cramped for space here. So we're going to replace u with the x minus 3 to the negative first. And now, let's continue. How do I solve these for x? Let's raise both sides of this to the negative first power. That gives me x minus 3 equals 4 to the negative first. So x minus 3 equals 4 to the negative first is 1 over 4. And add 3 to both sides. So 3 and 1/4 would be 13 fourths. With this one, raise both sides also to the negative first power, so you're going to have x minus 3 equals negative 6 raised to the negative first power. That's going to be 1 over negative 6, and we want to add 3 to both sides. So you've got negative 1/6 plus 3. That's negative 1/6 plus 18/6, so that would give you 17/6. So our answers are 13/4 and 17/6. Example 9, we're doing an absolute value equation. We know how to handle absolute value equations from an earlier section. The only difference here is that you've got a quadratic equation combined with the absolute value. We know that the absolute value equations gave us typically 2 possible answers. We also know that quadratic equations typically give us 2 possible answers. So be expecting to find 4 possible answers for these problems. How do we set this up? We've got the absolute value equal to a constant. So my rule is that I take the inside. Basically I have 2 cases. My first case, I just drop the bars. I've got x squared minus 2x minus 16 equals 8. My second case, I can drop the bars and take the opposite of my constant. Yet you absolutely must have both cases though, or it doesn't make any sense. Alright, so that's how I get it set up. This eliminates the absolute value bars by writing in this equivalent form. And now we've got two quadratic equations to solve. So my first one, I need to set the 0, so subtract 8. X squared minus 2x minus 24 equals 0. And does this factor? If I do 4 and 6, make my 6 negative and my 4 positive. So I've got x plus 4 equals 0, x minus 6 equals 0, x equals negative 4, x equals positive 6. Second one, add 8 to both sides. Negative 16 plus 8 will be negative 8. Does this factor? I don't think it does. Factors of 8 will be 1 times 8 and 2 times 4. Yeah, that does. 2 times 4 will work. Make your 4 negative and your 2 positive. So x plus 2 equals 0. X minus 4 equals 0. So x equals negative 2. X equals positive 4. Okay, we do generally say that we need to check our answers when we're doing absolute value equations. And that is true, but I know that these are going to work because I've got a positive constant. If I had had an absolute value equal to a negative constant here, then my answers would not have checked. So knowing that tells me that my answers should be good. So I've got negative 4, positive 6, negative 2, positive 4. And you can list them out as a solution set. Like this. That's our answers. For example 10, we have one leg of a right triangle is 1 centimeter longer than the other leg. What is the length of the short leg if the total length of the hypotenuse and the short leg is 10 centimeters? So we need a picture to get us started. So here's my right triangle. This looks like my shorter leg, so I'm going to call this one X, and I'm told that the other leg is, or one of the legs is 1 centimeter longer, so we'll call this one X plus 1. And we need a way to describe the hypotenuse. We know that what did they tell us about the hypotenuse? They told us that the total length of the hypotenuse and the short leg is 10 centimeters. So let's just temporarily label the hypotenuse Y. That way we can say that the hypotenuse plus the shorter leg, X, is equal to 10 centimeters. So how can I define my hypotenuse? Let's subtract X, so we have Y equals 10 minus X. So I can use 10 minus X to describe my hypotenuse. Because the hypotenuse, they said, was going to be because they told me the hypotenuse and the shorter side together were equal to 10. So we can express the hypotenuse as 10 minus X. Now we're ready to use the Pythagorean theorem. So I need to do X plus 1 quantity squared plus X squared equals my hypotenuse squared. These need to be FOILed out, so I've got X plus 1 times X plus 1 plus X squared equals 10 minus X times 10 minus X. So I'm going to FOIL, that's X squared plus 2X plus 1. And then over here I've got 100 minus 20X plus X squared. On the left I can combine like terms. X squared plus X squared gives me 2X squared. Then I need to work on getting everything on the same side. So I want to take all of the terms on the right and move them to the left side. So I can start by subtracting the X squared from both sides. 2X squared minus X squared gives me X squared. The negative 20X I need to move, so let's add it to both sides. And so that's going to give me 22X. And then subtract the 100, so I'll get negative 99. And this will not factor, so I need to use the quadratic formula. It's negative 22 plus or minus the square root of b squared minus 4 times a is 1, c is negative 99, all over 2 times 1. All right, so now I have x equals negative 22 plus or minus 22 squared plus 4 times 99. That's going to give me, I believe, 880. I did that already. I didn't do it off the top of my head. So yeah, it gives me 880. And then, because this is an application problem, most of the time we prefer decimals. So that's what I'm going to use here. So I'm going to set this up as x equals negative 22 plus square root of 880 over 2. X equals negative 22 minus the square root of 880 over 2. This is going to give me these are irrational numbers, so these are decimal approximations I'm getting here. So I get x is approximately equal to 3.83 and negative 25.8. Now, do those answers make sense in the context of this problem? We're doing the lengths of the sides of a triangle. So we can't, the negative 25.8 is not going to be helpful for us. So we're going to throw out the negative 25.8, and our answer is the 3.83, and this was in centimeters. And that completes section 3.4. So that should get you ready to do your quiz for Monday's class, and we will practice some more on Monday. So good luck with this.